you get this link, SPSS how to videos. So click on SPSS how to videos. Okay, so we're going to do we're going to do non-parametric analysis, and you're also going to do chi-square. So please click the top one here, number 2, click number 2, and also click number 3. Okay, right now something else happening. I'm trying to get it to be downloaded. Something else is triggered. Okay, it is already downloaded. Click open. Okay, so I'm going to extract. Kerja. I am recording. Okay, I'm going to extract the file now. I'm going to extract on the desktop. Okay, so you can see here for today's exercise, we got the usual data that we always play around with. We also got the data for the non-parametric. Okay, so now I'm going to open up SPSS. Okay, for the first part of the lesson, we have the slides already prepared. So we're going to follow the slide. We're going to follow the slide. Okay, which slide we're referring to? Slide number 3. How to run chi-square on SPSS. Okay, I hope you can see this slide. How to run chi-square on SPSS. Later on, you can download this thing and upload into your computer. How to do that? I just click here on the right side. This thing will open up in this file. Click the download button. Okay, click the download button. And it will download the file. So although it is now not on the Teams, you can download it yourself afterwards. Okay, or in case some of you do not know how, I will just upload it now. So how I upload it, I just go to your Teams. Okay, this list of files, what I do, I just click on edit. Edit. So I click edit. So now I can add another file from my computer. So from where? From the download folder. Okay. Can upload this one. Can upload this one. There's one file missing. Where that thing goes to? Okay. Yeah, let's see what happened to the missing file. When we click download, it is please press the download button again. Download. It's not downloading, I don't know why. Okay, finally it's downloading. Oh, tak jadi. I don't know. I don't know what is happening. Okay. PNG file, download. Tak. Okay, man. So you all can try to download from there. I just see whether I can see it inside my hard drive. Where it is. Hard drive. Okay, download. So dia tak ada desktop. Yalah, dia didn't download, don't know why. Okay, nothing much I can do about that. Okay, just pangkah. Okay. Okay, YouTube is done. Okay, so this is a slide. So by right, you're supposed to be able to download by clicking on this. They open up a new screen for you. Here. Okay. By right, when you click here on download, you're supposed to be able to download. And right now, unfortunately, it's not downloading. I don't know why. Okay. Never mind. Nothing much I can do about that. So don't worry. Let's go through the exercise. So how to run the Pearson Chi-Square? Oops. Okay. So basically, to run the Pearson Chi-Square is very easy. Okay. So the command that we're trying to do is trying to find relationship between mother's level of obesity and the birth, whether the baby is big or small. Okay, whether the baby is small for gestation age or not. Yes or no. So the weight is classified under underweight, normal and overweight. So therefore it is categorical data. The outcome is categorized to yes for SGA babies and no for normal babies. Therefore it is categorical data. The n is 200. The most suitable test is Pearson Chi-Square. Okay, I'm going to show you how to do Pearson Chi-Square. So how to do Pearson Chi-Square? You click on this one. Okay. What is you're going to do? You're going to run obese class against the outcome. Against the outcome. So you can see here, obese class is this one. What is 1? 1 is underweight. What is 2? 2 is normal weight. What is 3? 3 is overweight. Okay, so now we are going to run chi-square. To run chi-square is simple. Click Analyze, Descriptive, Cross Tab. Analyze, Descriptive, Cross Tab. For the cross tab, the risk factor we're going to click on obese class. So obese class, the outcome is outcome. Okay, what statistic we want? We want the chi-square. Continue. What do we want? We want the row percent. Continue. Okay. Once you're done, click OK. And you get the answer is like this. Okay, so the answer is like this. Looking at SGA, among underweight, the rate is the highest, 85.7%. Normal weight 54%, overweight is 26%. So those who are underweight are more likely to have SGA babies compared to the mothers who are overweight. And the p-value is very significant. Okay, it is less than 0.001. So to get the real value, you just double click, format cells, cell properties, click format value. You click this value until you get the number at the top there. Okay, this one. Okay, so you can see there it is 0. Okay, 1 2 3 4 5 7 8 9 9. It already got. Okay. Okay. So by having this decimal point up to 8 decimal, you can see the value of the p-value is 0.000000004. Okay, so let's look at the slide, how it is discussed. So inside the slide, it is discussed like this. Same as the weight of the mother increases, the incidence of SGA decreases. Okay, from 85.7 drop to 26.1, and the difference is statistically significant. I repeat, the difference here are statistically significant. You can see the rate of the disease among the different weight classes are different, 85, 54, 26. Since the rate are different, okay, we look at the p-value. The p-value says it is also significant. Okay, it is less than 0.0000004. Okay. Conclusion: a clear decreasing rate of SGA as the weight of the mother increases. Okay, the difference is statistically significant since the p-value is smaller than 0.05. Therefore, there is significant increase of rate of SGA as the mother's weight classification decreases from overweight to underweight. Or you can do it the other way. There is a significant decrease rate of SGA as the mother's weight classification increases from underweight to overweight. Okay, so that is how we decide. Okay, so that is the first part of the analysis using chi-square. This one you have to do 2 weeks from now during the exam, so practice. So please practice. And that is for chi-square. Okay, now we are going to go through the non-parametric exercises. We don't use this one anymore. Okay, so the non-parametric, the first one we're going to do, the data set that you download just now, is the Fisher's exact test. Is the Fisher's exact test. This is the data that we had during the class just now. Okay, this data that we had during class just now, which is kerja and obesity. Okay, it is this data set, kerja and obesity. Okay, so let's run this analysis. So we have the bus driver and the taxi driver. Okay, we have the bus driver and the taxi driver. We have the weight classes, underweight and normal. So for Fisher exact test, how it is done? Click analyze. Okay, cross tab. Okay, so the risk factor here is kerja, so row. The outcome is obesity, column. Okay, no need to press this one. No need to press this one. Okay, so you just click statistics, click chi-square. Okay, click chi-square, click continue, cells row percent, continue, click OK. You get the answer, and the answer looks like this. Okay, the answer looks like this. So you have 42.1, 57.9, 21.4, 78.6. Okay, again, I repeat, you focus on the rate of the disease among exposed and the rate of the disease among non-exposed. So you see the rate of the disease among the exposed, bus driver 42.1%. The rate of the disease among the non-exposed is 21.4%. So to 42 and 31, it is different, but it is not statistically significant. Why? Because the Fisher's exact test is larger than 0.05. So that is how we do the Fisher's exact test using SPSS. Okay, so the next one, we are going to do for the Wilcoxon rank sum test. We're going to do for the Wilcoxon rank sum test. Got two data set here. One is Man-Whitney taxi. The other is just Man-Whitney. So take the Man-Whitney taxi. So this Man-Whitney taxi is the same like the data set that we use just now. What data set? Oops. PowerPoint. I'm going to trigger back that set the Wilcoxon rank sum test. So this is a table that we did just now. So this is the data set. Okay. So we're going to run the analysis based on this data set. So we got kerja and we got the bus driver and the taxi driver. This is the glucose level. So we're going to run Wilcoxon rank sum test. To run Wilcoxon rank sum test, you click analyze, non-parametric. Okay, so this one is where you have to be very careful. Select legacy dialog, non-parametric, select legacy dialog. What do you want to do? You want to compare between two independent samples. You want to compare between two independent samples. Okay, so we have the grouping variable, which is kerja. and we have the glucose level. So we want to know which glucose level it is. So we're going to set for group 1 and group 3. Why group 1 and 3? Because that is how the data is coded, 1 and 3. Okay, what you want? Okay, since there is no Wilcoxon rank sum test in Spss, instead they have the man with EU. You select the man with EU. Once you're done, click OK. So you can see here, the p-value is not significant. The p-value is not significant. Okay, it sucks. Why it sucks? Nothing else to discuss except for that p-value. Okay, p-value indicate there is no difference of glucose level between those who drive taxi and those who drive buses. Okay, that is how we do the man with EU. Next. Next we have the exercise for Wilcoxon sign rank test. Wilcoxon sign rank test. For the Wilcoxon sign rank test, you have to use the data SGA pair non-parametric. SGA pair non-parametric. Okay, this is the HB level second trimester and the third trimester. Okay, I think we also have this data set. Okay, this is the same data set like the one we had in the class. It is the data set Wilcoxon rank sign test. Okay, we're going to use this because this one is easier to understand because we got the data set inside the slides. Okay, we click analyze. Again, non-parametric. It is related sample. Okay, it is related sample. Okay, now this one problem. So instead we use the legacy dialog. Okay, two related sample. So what are the two related sample? The BP level. What do you want? You want to do Wilcoxon sign rank test. So you click Wilcoxon. Okay. Okay, tak apa, option. Okay, if you want, you can ask for the quartiles, you can ask for descriptive. Not really, it does not really help because they just give for both groups combined, not separate. So for the Wilcoxon sign rank test, okay, you can see that statistically significant, the p-value is 0.021. Okay, so you can see mostly improving for the better. Okay, so you get the mean rank 19.48 versus 12.67. So for this, we have shown that the BP drops after the patient waited for 10 minutes. Alright. So that is the conclusion that we can make from that Wilcoxon sign rank test. Next. We already covered Wilcoxon rank sum test. We already covered Wilcoxon sign rank test. Earlier we already covered Fisher, and we already covered chi-square. Next is Kruskal Wallis. Next is Kruskal Wallis. Okay, so you got 3 machine. Machine 1, machine 2, machine 3. Okay, so we want to do Kruskal Wallis one way ANOVA. How do we do? Analyze, non-para, okay. Click on legacy dialog, K independent sample. K independent sample. Grouping variable is machine. The test variable list is master. What you want to do? You want to do Kruskal Wallis test. Okay. For the machine, we have the minimum value of 1, maximum value of 3. Click OK, click continue. So you can see that the mean rank for machine 1 is 13, machine 2 is 7, machine 3 is 3.4. Okay. So yes, this is significant. The chi-square is 11.58. The p-value is 0.003. Okay. Okay. So that is how we do Kruskal Wallis inside Spss. So you can see there, it has shown that there is a significant difference of time between the 3 machines. The fastest machine is machine 3, followed by machine 2, then followed by machine 1. How do we know that? Because the ranking for machine 3 is the smallest compared to machine 2 and machine 1. Okay. So that is the Kruskal Wallis test. And next, okay, apparently this is the last one. Okay, Spearman. For the Spearman test, this is the analysis between the two dataset, between glucose and the blood pressure in terms of systole. Is there any association between glucose level and the blood pressure? So you click analyze. Okay, non-parametric, legacy dialog. Oops, sorry. We want to do Spearman. Spearman is under analyze, correlate, bivariate. Analyze, correlate, bivariate. So you click both glucose and blood pressure 1. You select the analysis. You want candle and Spearman. Once done, click on OK. Once you click on OK, you can see that the value for the Spearman row is 0.59. Sorry, the row. We are talking about the row. Is 0.097, and the p-value is not significant because it is 0.599. Okay, so that is for the Spearman correlation. Okay, so with that we finish the last one. We finished the last one. So we have recovered everything. So what have we covered? So what have we covered in terms of Spss? We started with chi-square. Then we did Fisher. After that we do the Mann-Whitney. After that we did the Wilcoxon sign rank test. Okay, after we did the Wilcoxon sign rank test, we showed you all how to do Kruskal Wallis. Then we showed you how to do the Spearman. Oh, still miss one. We still miss one. We have not yet covered McNemar. Okay, so for McNemar, can show the Kruskal Wallis again? Can, no problem. Okay, Kruskal Wallis. Hello. Salam. Aha. Tak, sebab saya bayar untuk yang 500 Mbps. Tapi saya cuma dapat kurang per 100. Jadi tak, dia tak datang. Dia kata dia buat peluar je. Sekarang ni ada. Okey, terima kasih. Okey. Ya, sorry. Telekom datang 10 minit lagi. I better finish the class in 10 minutes time. Okay. So Kruskal Wallis, this okay. I'm sharing the. I hope I'm sharing the screen. Teams. Okay. Okay, sure. I'm going to share the screen. Desktop. Okay. For Kruskal Wallis, we click Analyze, Nonparametric, Legacy Dialog, K Independent Samples. K for Kruskal Wallis lah. So machine, you transfer the grouping variable to machine, define range 1 until 3. Masa, click OK. Okay, so then you get the answer. The machine 1 min rank 13, machine 2 min rank 7.6, machine 3 min rank is 3.4. P value is significant at 0.003. Okay, so that is for the Kruskal Wallis. Okay, I just realized I did not give you all the data for McNemar. Okay, so I'm going to upload to your Teams. Okay, so I just upload the data set. Okay, upload from my computer. Spss. Oops. McNemar. Okay, I'm going to upload the data for McNemar. Okay, I'm sending it to you all. Okay, so when I click the data, download. Okay, when I download the data, by right it's supposed to trigger the SPSS. Okay, this is SPSS. So for McNemar, this is the last one. Click Analyze. cross tab. Okay, so before is row, after is column. Okay, ayo, sorry, ayo ma, ayo pa. Okay, kejap kena masuk balik Teams, join, share. Okay, sudah masuk balik. I'm going to show you SPSS. This is SPSS. This is dataset McNemar. I'm going to click Analyze. Okay. Cross tab. So under row, it is before. Under column, it is after. Okay. So what do we want to do? We want to do statistic. What statistic you want to do? McNemar. Why? Because this is before and after. Click continue. Okay, cells. You don't ask for row percent. You ask for total percent. Okay, you ask for total percent. Click continue. Click OK. So you can see here the McNemar, it is 0.016. And that is how we do McNemar analysis inside SPSS. And with that, we are done for the day. Feel free to ask any questions inside the Facebook. Okay, I'm going to post this thing afterwards. And thank you very much for your attendance today. I hope the attendance is real, not just log in then terus balik kampung. Alright. Okay, bye. Take care. Thank you. Thank you. Thank you. Ni Kiasho tanya kenapa total percent. So that is specific for McNemar, sebab in McNemar we are interested in the total percent because we are not looking at the row percent, because inside the McNemar we are looking at accuracy. So accuracy is before and after same. Remember concordance pair. So level of accuracy is A plus D is the level of accuracy. So you know, you want to know the percentage. Okay then. Okay, bye. Ame. Telecom.